Hello, welcome to my English garden, and today we're going to do an example of kinematics. So let's say that you are stopped in a highway and you start accelerating at 1.8 meters per second squared for 10 seconds. You are driving at that velocity for 30 minutes, and once you're there, you hit the brakes and you start decelerating at 3.25 meters per second, or accelerating at negative 3.25 meters per second squared. We want to find how far did you go in the entire drive, and how much time did it take you to get from when you started till the very, very end. So it doesn't seem like we're given a lot of information, but we'll work with what we have. So first we want to find our velocity after the acceleration that we did. So for that we use the first equation, which is v at some time equals initial velocity plus acceleration times time. We don't have an initial velocity. We were at 0. We were stopped. So AT is the only two pieces of number we have, which is 1.80 times 10 seconds. So V of t equals 18.0 meters per second. So we start with that. So we now have the velocity of those 30 minutes that we were traveling, because we stay in that one velocity for the entire, let's say, highway. So we need to find first how much distance that we travel in that acceleration process as well, because we're going to need that for the end. For that one, we can use equation number 3. Equation number 3 states that final distance, or distance at some time, is initial distance plus velocity times time plus 1/2 AT squared. We don't have, or rather our distance is 0 because it's where we started. Velocity is 0 because we were stopped. So we're just left with 1/2 AT squared. Those numbers are 1/2, 1.80 times 10 seconds squared. So our t, or our distance at some time, is going to be 90 meters. So that's good. So we have our first piece of distance. So let's write that down a little corner right about here. So now we're going to find out our distance, the distance covered at those 30 minutes, including the 90 meters that we just traveled. So this is the velocity, so we're going to put 18.0 here, just to remind us. So now for this we're going to use the second equation, because there is no acceleration in those 30 minutes, so we can just use the second one. So r at some time equals initial r plus vt. Our r initial is going to be the 90 meters, because that is the distance that we traveled during our acceleration. Plus velocity, which is the velocity at that time, at those 30 minutes, which is 18.0, times 30 minutes. In physics, we don't like minutes. So we're going to change it to seconds. So we have to do dimensional analysis, where in 1 minute, there are 60 seconds. Minutes cancel out. 30 times 60 equals 1800. seconds. This is the time that we put into this equation, because this time is in seconds. If it's not in seconds, it's going to give us a different number. It's in meters per second. This is in meters. So we calculate that, and we have that our distance at some time is going to equal 32,490 meters. So now we can erase this and write 32,490. So this is the total distance we've covered from since we started till the end of those 30 minutes, which is just before we start, hitting the brakes. Now we're going to solve the distance that it took us from when we started decelerating till the end. We need to find the time it took us first. So we're going to use our first equation, again, which is v of t equals v initial plus at. Assuming that we decelerate till we stop, our velocity at that time is going to be 0. So we have that initial velocity is 18 meters per second, because that is the velocity that we had before we started braking, plus our acceleration, which is negative 3.25, times, well, the time that it took us. We don't have that. So we're going to solve for t, so we move this to the other side, turns into a negative, and then we divide by negative 3.25. So t is going to be equal 18 over 3.25. Negatives cancel out. And that is going to give us t equals 5.54 seconds. So that is the time it took us braking from 18 meters per second to 0. So this is our time. We're going to write this one out as well. 5.54. Now we are going to solve, I would say, our final distance. Finally. No pun intended. So we're going to use equation number 3. Equation number 3, which has all of these things. Our distance at some time equals our initial distance plus vt. Let me change that. Vt plus 1/2 at squared. So we're going to solve for this. This is our final distance. Our initial distance is our 32,490. 32,490 plus the velocity we had at that time, at that specific moment before we started braking. So it's going to be 18 times the time it took us to brake, which is 5.54, plus 1/2 our deceleration times time squared again. We just want RT, so you just do this math in your calculator, and you'll get that our final distance is 32,539.8 meters, roughly. So this is our final distance, the total distance traveled in the entire thing. So we can just write that out here. Perfect. Now we're going to find the total time it took us. That's a lot easier because we already, solved for all the times that we needed. So it took us 10 seconds to do our acceleration, 1,800 seconds in the travel time, and 5.54 seconds in the deceleration. So it's a lot simpler than it looks, than it sounds, actually. So you just do that, and you get that your total runtime is about 18,554 seconds, which you can just round up to 1820. And that is the entire distance covered. I mean, the total time it took you to travel, and the total distance. I hope you enjoyed this example of kinematics. Check out my other videos on My English Garden for more physics stuff.